Hi, this is Luiz from SideFX, and in this talk I'm going to be sharing our automated photogrammetry to game res pipeline. This is something that we've been working on for close to a year now, so we're really excited to be able to share it with everybody. Alright, so this is what a mesh pipeline generally looks like. You're starting with something that is high res, drop it down into something that is game res. Then you need to add UVs so you can transfer the information from the high res down to the game res. And that process is called baking. So you need to bake all your maps out, and then you need to get it out into a game engine or wherever you're going, maybe a website. So currently that pipeline is heavily fragmented. So on the high res source, there's ZBrush, there's multiple softwares that you can do sculpting and high res modeling. And there's also photogrammetry and different solutions that you can do to generate your models with scan data. Then for decimating, there's lots of different options out there. You can do things manually, you can do things automatically, wide variety of softwares for you. Same goes with UV. There's some that are very specific for only UVing, and then more general packages that do a little bit of everything. And baking, there's quite a lot of highly specialized bakers out there. Most of them do amazing jobs. But again, it's just another step that you have to go through, and now you need to export all your objects from your software, kind of get them all lined up, import it into the other one, bake, kind of manage all of those files and things that you might not necessarily want to do. And then when you're finally done, you need to be able to kind of wrangle all your files together and then export them out either through a custom script or you kind of just manually handling a lot of files. So what we're trying to propose here is that you can use Houdini for all of these operations. Even if you do have to use another software to kind of either do sculpting or run photogrammetry, the idea is you can use the Houdini as that kind of backbone spine for your pipeline, so you minimize the hopping back and forth as much as possible, and you let us handle all of the kind of file I/O that no one likes to deal with. So let's start by looking into each of these different pipelines individually. So starting by the high-res source. The two ways that you can get the data generated traditionally now, it's either you're doing something with scans or you're sculpting or kind of modeling it. First, we'll go into the scanning process, which seems to be gaining a lot of popularity at the moment. And for those that aren't familiar with photogrammetry, the general idea is that you have a camera setup or just a camera that takes lots of pictures. In this case, we've been working with 1024. They're up in Sheffield, England, and they have an amazing capture studio. And they've been generous enough to be able to kind of give us some of those pictures to do some testing. So they have this really nice, it's over 100 cameras, and basically you can take all of the pictures with all the cameras in a single shot, which lets you capture humans very easily. Because if you have a subject that is moving a lot, the photogrammetry software doesn't really like when things move. So by taking all of the shots at the same second, you can align them a lot easier and be able to kind of capture them and minimize the amount of error you get. So you start off with all your cameras, you take lots of pictures, and then you take all of those pictures and you feed it into a photogrammetry software. What the photogrammetry software does, it finds out interesting points in those images. It triangulates those positions so you can figure out where the cameras are. And by triangulating where the cameras are, it can actually generate a 3D model from those images. So this is incredibly powerful because now you can basically just walk around an object and capture a bunch of pictures and you get a 3D model from it. So instead of having to use something like laser, it kind of made it scanning a lot easier. And the output of a photogrammetry software is a high-res model. So in this case, you saw those images on the previous slide that we got. And this is the final output of a high-res model. I think this one has around over 20 million polys that is outputted. So photogrammetry at this point is pretty standard in the industry. You're probably watching this video because you already at least know about it or you're kind of interested in. This is mainly due to two big players in that field. DICE is an EA company that does Battlefield and Battlefront, and they've done just amazing work on that photogrammetry pipelines. And they've shared a lot of that work on GDC presentations. So I think that was almost like a trigger that pushed the industry to adopt photogrammetry. And also Quixel with their Megascan library is another just massive library of high quality 3D scanned assets. Between those two, I think now most studios are aware that you can get really high quality game assets using this process. And we're happy to be able to say that we're working closely with both of them on developing the kind of Houdini photogrammetry pipeline. So we're very lucky to have them kind of working with us and giving feedback on where we should be doing. So on the photogrammetry software side, there's three main players. Autodesk has Recap, which is really powerful, but a little bit focused more on the industrial sector. Photoscan has been around for a while, and it's usually the first software that people took on early on in photogrammetry, and some still have a pipeline that is based around it. We found that it's a little bit on the slower side. where the processing of the pictures was becoming a bottleneck on our pipelines. Then recently Reality Capture came out and just is incredibly high quality and fast. So for that reason, we've decided to partner up with them and actually write a plugin for Houdini using the Reality Capture SDK. So here we have a scene where I'm showing the Reality Capture plugin being used. And in this case, we have something that is, I think, around 6.2 million polys. And this is something that I scanned in New York, just went around an object in a museum and took lots of pictures. And here you can see on the network on the right-hand side that I have the Align Images node, which basically just takes a bunch of pictures as the input coming in from outside the screen. Then we can use regular Houdini nodes to generate a bounding box that feed it into a create model node that will generate the kind of 6 million poly mesh. So it's a very simple process. Only really 3 nodes that you have to care about. If you want to get a little fancy and do a bounding box, you can add that in. But the idea here is trying to make it as easy as possible. So there's actually 4 different nodes in this kind of Reality Capture plugin. The first one is to register images, and this is just basically a file browser that stores your list of images. You feed that into the Align Images node that gives you that point cloud. After that, you either generate a bounding box or you just feed that point cloud straight into the create model node, which then, as you would expect, creates the models. And then additionally, we have the ability of extracting the cameras. So here we have a picture again of some 1024 data. And this is just to be able to see where the cameras are. And you can do kind of some post-processing on the model based on where the cameras are. So you can delete things that are behind cameras. Or we think that for film studios to be kind of useful if you're trying to do kind of camera matching. The nice thing about also having the camera positions is that if you have a fixed rig, and if you align it once, we can store the positions of those cameras and then basically store a delta of where those cameras should be. So if you have a fixed rig, you can always get the same result every single time. So on the licensing side, it currently works with regular Reality Capture licenses. Even the promo license, it works. Just like you authenticate your license inside of Reality Capture, that little window happens inside of Houdini now. So you can choose which of your licenses you want to use, how long you want to extend it for, exactly the same idea. We are limiting it for no command line usage unless you have their CLI license. And the reason for that is that they do have their own command line product that we don't want to infringe on. So for now, there's a little pop-up that happens just to make sure that you're a person and you're not just kind of batching lots of things. But there is going to be a new licensing model coming soon, and I'll let them announce it, which will allow you to use the plugin with a command line functionality at a different pricing model. So I'll let them announce that when they're ready. But the idea is that the plugin is ready to go and you can kind of start building your pipelines now and use it with the licensing that it's in place. And then as the licensing gets updated, your pipelines will just continue to work. So one of those kind of workflows that we're starting to play with is delighting. So there's no really perfect solution for delighting as of yet. And we're kind of keeping an ear out. If you know of anything, please let us know. What we found talking to people is that it's a lot of different little hacks that people do to kind of try to get the images calibrated. So the 2 main ones that people tend to do is they'll take the ambient occlusion and then just brighten the value of the image a little bit. And then the other one is basically they fake a directional light and then they pump up the brightness a little bit that way as well. So we have a couple of nodes that we're going to be releasing that basically just do that. We do convert the vertex colors into hue, saturation, and value, and then we pump up the value and let you kind of counter the saturation a little bit. That seems to work pretty well, but I'll let you guys be the judges and let us know how we're doing. And then we'll keep adding more different delighting tricks. The nice thing is that because we're Houdini, we can actually do all of those operations on the high-res asset itself, as opposed to kind of doing it as a post-processes on the images. So we find that you get slightly better results by being able to calculate that on the model itself. And then next, if you're not coming in through a photogrammetry pipeline or a scan pipeline and you just have a sculpt from ZBrush, you can just shoot that straight across. So we have a GoZ bridge that works pretty seamless. We've done an update now that makes it even more intuitive. And we do pull a lot of information from the GoZ files. So we do have all the subtools, all the polygroups, polypaints, masks, and UVs, and it all works as you would expect. So the idea there is you can quickly shoot your model over if you're coming from ZBrush, and then you can kind of take over that pipeline and just do your regular game resing work inside of Houdini. But the nice part of having that ability is that after you've done your base cleanup inside of Houdini, basically deleting the floor and kind of doing a a fast cleanup pass, you can actually just shoot your high-res model over into ZBrush because it's a bidirectional bridge. And then you can do any kind of noise smoothing or anything that you might want to kind of just manually update on your photogrammetry assets as well. So now that we know how to handle the high-res assets, let's look into how we're going to decimate it down and getting into a game res asset. So with Houdini 16.5, we've added a new polyreduce, which is incredibly powerful. And in this case, I think we're dropping it down all the way to 500. So it's easy to show something that decimates down to 10,000 polys, but we want to see something that decimates down to the hundreds and still holds up. The nice thing is that we hold up the UVs pretty well, and we feel like we're doing a pretty good job of kind of keeping the integrity of the model. Because we're Houdini, you have full control again of all the attributes and how you want to decimate things. So in these two examples, we have something being decimated by vertex colors. And on the GDC demo that we did, we also have that chip that we decimated based on our position closest to the camera. So the idea here is we knew that the camera was always going to be on the back of the ship. So we wanted more resolution to be biased towards the back of it. So we just did a gradient and then we polyreduced based on that. As a part of the game development toolset, we also added this voxel mesh node, which just simplifies the ability of kind of going into volumes or voxels and then back into polygons. So the idea here is if you have a lot of interpenetrating geometry that's kind of crashing into each other, you can convert that mesh into a voxel, which deletes all of the interior faces, and then it can convert them back into polygons. So this is really useful if you just want to kind of get a clean low res from something that was maybe kit bashed a little bit. And we also have an integration with Instant Mesh, which is an awesome open source quad remesher. It just uses the command line interface to Instant Mesh, but it does a really, really nice job of quad remeshing some of the assets. Okay, now let's look at what we can do on the UVing side. So with Houdini 16.5, we've added a new UV layout. So the idea here is that it just packs things very, very tightly, and it packs things inside of concavities and holes. So any negative space inside of a shell, we can use that to fit things in. And the nice thing about here is that not only you're packing a single object, sometimes you want to combine maybe something that had 7 materials and you want to drop that down into a single material. So in the case on the right, that's what it is. It's a character that it was pre-UV'd. It had 7 different materials. So we can kind of combine that down into a single material, pack all of those UVs very, very tightly, and then bake out a new mesh or a new textures based on it. Here's a direct comparison of what UV layout used to do versus UV layout 2 on the same exact model with the same exact UV island. So you see we get a lot better textile usage out of our textures. So with Houdini 16.5, we also introduced in the recent production build a new version of UV Flatten. And what this does, it just handles the textile distortion a little bit better. So UV Flatten had a lot of issues where you would get some pinching and some stretching. And with the new version, it basically fixes all of that. So we're pretty happy to have that as part of our workflows. So because now we've added the new UV Flatten and the new UV layout, we can start building higher level tools on top of that. And as part of the game development tool shelf, we have this auto UV SOP. And here's some of the experiments that we've been doing with it. The idea here is on the bottom, you can see here's what the ground truth or the actual asset from Megascans look like. And we're assuming that this was kind of cared for and the UVs were really well done. And then on the top, here's a few different modes that we have on our auto UV SOP to see how close we can get to that. The first one is shortest path. And the idea here is you're just finding interesting points in the mesh, and then we're drawing shortest path to kind of define your seams that way. The next one is clustering. And this basically just clusters polygons that have same normals that are close enough together with each other. And this gives us pretty good kind of island coherence. And then the next two actually became combined recently, where we had this axis align that what it did was it did a projection, much like UV unwrap, but it also had a little bit of logic in there to merge small islands back into itself. This example might not be the perfect one, but on the next slide I have something that shows it a little bit better. And then the UV unwrap is your traditional UV unwrap that we always had. But by adding that merge small island features, we actually get something that doesn't have all of those little explodey islands and actually starts looking pretty close to what the original asset looked like. So in this, the current version of the auto UV SOP, the axis align mode has been deprecated, and you only have the three, the shortest path, clusters, and UV unwrap. But we have this awesome new merge small island features. So it basically does what you expect. You have lots of little islands that are generated because of the way the projection works. And then there's just a threshold that you can control to essentially suck those islands back in to the main larger shells. So you can go as far as kind of pushing it all the way to where you only have 5 big islands, or based on the amount of distortion you're getting, you can kind of pull that back and have a little bit of smaller islands, but maybe a little bit less distortion. And for people that don't like looking at rocks all day, I've also added in hard surface example of showing what the auto UV can do on it. And this one is actually even easier to do because the hard surface object is very easy to be able to kind of define where those normals are splitting or where those planes are. So it's even easier than an organic object to be able to automatically UV it. So next up, now we have a game res model that is automatic UV'd, and we want to bake the maps over. So we have the games baker, which cleaned up the interface significantly from the original bake texture node. So on the right, we had the original bake texture node, which is basically a wrapper around our Mantra renderer, which is just a heavy duty film renderer. So there's lots of options. And we just made an interface that was a little more familiar to artists. So it's something that you just say, this is my high res mesh, this is my low res mesh, this is the resolution, this is where I want it to go, and these are the channels that I want to bake. So something a little more intuitive, and you have to deal with a lot less advanced features, which are still exposed, but you might not want to go through those directly. And in an effort to make that even simpler, we've added the simple baker. And what this does, it works in our SOPs context, which is our geometry. So instead of having to go into this other context for exporting things, you can do the baking directly from here. So it takes 2 inputs. The game res is the first input, the high res is the second input. And it's the same interface that you had on the ROP side, which is our render operators. So here you can set your resolution, you hit render, and the nice thing is that once it's done baking, it will automatically apply the normal map and the ambient occlusion map by default, but you can also change that to be any other maps that you might have been baked out. Here's the final bake, so you can see it just automatically assigned it. So you don't really have to manage again, just now I bake my textures, I need to go and make a material and assign it. We know that you baked it, so you want to see the results, so we might as well just kind of help you through that process. And then finally, you want to get this data out. So it's very easy to kind of get data out of Houdini. It's easy enough to write a custom exporter if you have something that needs to be specific for your engine. We do provide samples, one for a CSV exporter that just kind of lets you run through a mesh in Python. And we also have a C++ interface that we use for generating both the GoZ bridge and the Reality Capture plugin. We also have FBX exporter, as you expect, and we've done a lot of updates to it. We've made a lot of better file handling on the kind of importing and exporting, keeping attributes and keeping materials and things of that nature. We can also export LODs and skeletons a lot better. And the best thing is that we made it open source. So now if you have a question about it or you want to see what it's doing underneath the hood, you're welcome to just kind of look at our GitHub and see exactly what it works. The other big announcement for this presentation is that we're releasing a SKETCHFAB uploader for Houdini. So the idea here is that from our render context or from our geometry context, you can just upload directly your models into SKETCHFAB. So here's that ship model that we did for the racing game. We just drop a SKETCHFAB node immediately after doing this pipeline, and it just shoots it across over to SKETCHFAB. You don't have to export your textures, put them in a zip file, kind of manage everything. You're just natively from inside of Houdini, you can do it, which is really cool because now you can go essentially all the way from taking pictures and using a Reality Capture plugin to generate a high-res source, all the way to exporting it into SKETCHFAB in a single shot. So it's pretty exciting. And you can see now we kind of addressed all of the different pieces of the pipeline with different pieces of tech, and we're continuing to build up on this. So we're pretty excited about what we have and where we're going. Because the Reality Capture plugin is the kind of main thing that people have been asking for, I've also added a couple more examples of what that looks like. So here again is another file that goes maybe a little bit deeper into that workflow. So here you have the 168 images that we got from 1024 again. I'm very grateful for those. Then we have the align images node. We're deleting some points that we want, so we're isolating that selection, generating a box around it, and then feeding into the create model node, which gives us the 18 million poly model. You can see the quality here is pretty astounding. You get down to the stitching level, and this again is just geometry. And you're looking at the wireframe mode here. After that, we have a little bit of work to do, so we can clip the floor out. So that basically just draws a line and says anything above this line is deleted. And then we can also delete small parts very easily just based on a threshold that kind of gets rid of all of the little floaty bits. And then we can do a polyfill to kind of cap those feet. So now you have something that looks pretty good. At this point, you can hop over to ZBrush. So we can drop in that GoZ node, go into ZBrush, play around with it. You can basically go in and start polishing maybe a couple of things that you didn't like. Or we actually bundled all of those nodes together that we showed into a single node, and we call it the GameRes node. So we can drop it down, and this, I think we're already looking at the 15,000 poly with a 4K texture baked. And instead of having to drop a bunch of different nodes, you just drop in a GameRes node and it automatically UVs. This is what the UV looks like. We've done some work since this video to kind of clean a little bit of the kind of explodey shells and make the shells a little bit smoother. Here you can see the reduction, the GameRes, what it looks like. And again, we can see the source, which was 10 million polys, and then down to the final, which is 15,000. And it's pretty hard to tell the difference. Maybe it's a little blurrier because of the resolution difference, and the silhouette changes slightly. But for the most part, this is kind of ready to go. And you really didn't have to do any work for the most part. It takes around, I think, 2 to 3 minutes depending on your resolution. If it's a 4096, I think it took closer to 10 to do the bake. But still, you're kind of going from 18 million polys down to 15 in minutes, not hours, which is really exciting. So here's another example of that GameRes node. Again, just taking that high-res object that we saw in the very beginning of the presentation and automatically completely decimating, doing the baking and doing everything. So here you have direct comparison again of completely automated mesh that is, I would say, pretty close to kind of good quality to put this in a game. Here's another example. In this case, we're running it at real time of me just going from ZBrush, taking an object, and then doing the whole process of kind of getting a GameRes and running through GoZ. So starting at ZBrush, I press that GoZ all. It's going to drop in a new mesh, load it in. And by default, Mike Pavlovich, who did this asset, leaves in this kind of star asset for naming sakes. So we can easily just select it. The poly group or the subtool names are actually name attributes, so they kind of are special in Houdini and they show up. So all you have to do really is drop in that GoZ mesh, drop in a blast to kind of isolate anything that you might not want, and then drop in that GameRes node. So here you can see in the bottom, it's doing the packing. Now it's starting to do the baking, and it's automatically decimating it down to 15,000, auto UVing, and then triggering the bake of the texture. I think by default is a 512, so it's a little bit responsive, but you can definitely do higher. And here you can see it was around 30 seconds that it took to do the whole process. In this case, the UVs fell apart a little bit, and that minimum small island cutoff was a little bit too big, so it was a little too aggressive, so I can just change that. It's going to take a couple of seconds to cook, and you're going to see that little area that failed. Now it's going to be resolved. So here we got new UVs. This is what they look like. If you saw the before, it would have had a couple of issues. So we can go back, see what the source looked like. On the reduced, we're seeing it's a little probably more resolution than we need, so let's drop that down to 5. The nice thing about the poly reducer is that once it's done the calculations once, that internal knowledge of the model is cached. So kind of playing around and changing the resolution it's pretty much real time, so you can actually scrub through and take the model to exactly where you want to do. There's some extra settings to automatically reduce based on quality tolerance, but for this case we can just scrub and kind of get a feel for what we want. And in this case, we went from that 15,000 down to 3,000. Those changes that we did to the automatic UVing will be retained because of the non-destructive nature of Houdini. Even though the poly reduction happens before the UVing, that auto UV updates will kind of stick. And now we baked, and here we can see this is what the final GameRes model will look like. And I can actually change the diffuse map to be base color instead of AO. So here you can see it's pretty damn close to what the original source looked like. There's a little bit of difference on the spec, but the quality itself is pretty close. So here I actually turned the roughness a little bit, so we're even a little bit closer to the final, or to the original source. So now you can see in, I think it was 3 minutes what this video had, probably a little bit less. We went from ZBrush to having a game res asset with baked textures ready to go into any other part of your pipeline. And again, it's really nice because here in this file you can have all the way from images to getting something in SKETCHFAB. And let's count it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes. So that Houdini has a little bit of a stigma of being hard to use or maybe a little bit too technical, but we feel that we've done multiple strides on making this an artist-friendly pipeline. Even if you never use Houdini, it's still fairly straightforward to kind of follow along. And now you can go from using reality capture to using it inside of Houdini and going all the way from the images to having it modeled up on SKETCHFAB in a very short time, and more importantly, in a single package and a single file that you can kind of manage and update and make changes as things are necessary. So thank you so much for listening to this talk. My email is luiz@sideeffects.com. Please ping me on the comments for any questions or just shoot me an email. We're going to work on making the reality capture plugin available in the upcoming weeks. But if you have a specific need or you really want to try it out, or you have some feedback that you'd like to see specific features, please don't hesitate to let me know. We're looking for feedback right now. So thanks for watching.